All right, so IP address, or do we want to talk about IPv4, right? So yeah, so I mean, what is the format, how it's defined, what are how many bits, and what's the format, how it's actually defined. So what we discussed, I mean, this is, you can see a representation of IP address and how it's represented. So I mean, it's basically what you call, it's generally what you call it as a logical address, right? That's what it is, and it's a 32-bit format, right? And what we have is 4 octets. So I mean, 4 blocks, what we call it as octet, yeah, separated by let's say, I mean, let me give you an example. For example, 192.168.1.1. So this is one block, this is another block, this is another block, and this is another block. So these blocks are actually called as octets. And what you are seeing, it's a hexadecimal format, right? This is for our interpretation. But what any machine, router, computer, or anything understands is the binary format. For example, this is the decimal format, right, for this IP, and this is the conversion into binary. So I hope everybody knows binary to decimal and decimal to binary conversion. I'm not going to cover that. Okay, it's pretty straightforward. So there is nothing very fancy in it. Yeah, so separated by 4 blocks, and then each block is again 32-bit. So each block is 8 bits, right? What we call it is an octet, and assigned in decimal format. Yeah, and there could be 3 different kinds. For example, like unicasting, or multicasting. That's what we discussed earlier as well, when I think we were discussing in general about the addressing and the broadcasting. So these are the major, I mean, 3 broad classifications of the IP addresses, you can say. And at the moment, what we're gonna see, or what we're gonna learn is, I mean, in general, they are separated into 5 classes, right? Class A, B, C, D, and E, right? So yeah, and now let's talk how these classes are defined, and how what range of IPs fall under which particular class of the IP addresses. So I mean, this is pretty straightforward. What you see here is the structure. If you want to take a snapshot, you can. So yeah, 8 bits, like I said, and class A, class B, class C, and D and E. We are not going to discuss around E. This is research, and it's useless for us. So class A, the first octet, what we see is, I mean, if you see, I mean, the first octet, what we call, I mean, what we discussed also is, I mean, IP address is what? Network address, I mean, network bits plus host bits. Yeah, 1 second. So in the class A, the first octet is known as network bits, which are basically, I mean, 8 bits. So there are 8 different places, right? What we discussed. So 1, 2, I mean, it gets doubled at. So and then .x, let's say .x. These are nothing but what you can say the host bits. Yeah, and these are the network bits, class A. So I mean, if you see how, I mean, for you, for example, let's say I'm gonna take. Let me tell you about the range, or let's talk about these eight places. How we can start, or how actually my router or any device, how does it recognize whether it's a class A address or a class B address. Yeah, so that we'll talk, but let me talk about the range first. I mean, or maybe you will understand how this range is determined. So this is the first place from network perspective. So how it is how a machine recognizes this bit is set as 0. So when this bit is set as 0, any machine or any router switch computer can understand if this bit is set as 0, that it's a class A address. So what are the 7 different spots available? Are these 7 addresses. So I mean, what could be the number of addresses? For example, I mean, we are setting it to 0, and then the rest of places could be 0 or 1. I mean, the permutation combination of basically 2 to the power 7, right? Because I mean, these are 7 places, and what could be 0 and 1? So 2 to the power 7 is how much? Anyone? 64. It's straightforward. I mean, you are here, right? So 64 different networks can be, network addresses can be in this class A. So we are talking about class A addresses 2 to the power 7, because the first one is reserved. Also, that is how you are recognizing it, or any machine is recognizing it, that it's a class A address. And then let's say starting from here, what could be the lowest value? Maybe 0. Let's say here it's also 0, 0, 0, 0, 0, 0, all zeros. So the first address could be like 0, 0, and then dot x, dot x, dot x. These are host bits, so I'm not writing anything at the moment. So this is basically 0 dot x dot x dot x. Yeah. And what could be the last address in this class A, when all these remaining bits are 1? So if you calculate it, what it's gonna be? Anyone?
Sir, I think 2 to the raised power 7 is 128 and 2 raised to power 6 is 64.
Correct. Again, are you sure?
Yes, sir.
Yes, sir. 128.
1 second, guys. That's right. So I mean, coming again to the number of addresses. I mean, the last address or the maximum bits, what it can be. I mean, all 7 could be 1. So let's say 0, 1, 1, 1, 1, 1, 1, 1 dot x dot x dot x. Yeah. So if you calculate this, if you count this, what it's gonna be? Can anybody sum it up? It's pretty straightforward. 3, 7, 15, 31, 63, and then what? 127. It's 127.x.x. 1 second, somebody is waiting in the lobby. Yeah. So what could be the range? The first address, I mean, let's talk about, I mean, some of the addresses in the middle. For example, there could be a scenario when, let's say, 8 places. This is always 0. This is 0. This is 0. This is 0. Let's say this is 1. This is 0, 0, 0. And again, these are the places like this. Yeah. So you tell me what would be the network address for this one? This place is 1. So what it's gonna be for this? It's pretty easy, right?
Sir, 8 dot.
8, of course, 8. 8 dot x dot x dot x. So the very first is, I mean, let's say now I'm considering all host bits as 0, because when all host bits are 0, that represents a network address. Okay. And let's say the last network address for class A is 127.0.0.0. But then these 2 addresses in class A, they are not used anywhere. Okay, this is not assigned to anyone. So first of all, I think I should have mentioned there are 2 international bodies which are majorly responsible for certain things. One is known as INA, and I think another one is ICANN. So these are the bodies who, one of the, I think INA manages the entire IP addressing, and then, I mean, and the DNS, root server allocation, how they are managed, the DNS records and all. So what INA does is basically it manages or the allocation of IP addressing to the organization or the ISPs. So what INA did is, this is not assigned to anyone, and this particular you know range of IP address is not usable. This is again what we call as a local host or loopback range of IP. So they are not used for the general assignments. There is a separate use for this particular subnet, but this is nowhere used. So what are the two subnets which again you can say comes after this? The very next lower value could be when this place becomes 1. So basically 0 0 0 0 1. So basically 1.x.x.x. So the very first usable address in class A would be 1.x.x.x. Yeah, and the last would be actually 126, because 127 can't be used. So the last one is 126, the highest value. So when it's 0 and rest are 1, then that is 126.x.x. Yeah. So these are the ranges in the class A. So if I to say class A, it's basically 1.0.0.0 until 126.0.0.0. And there is another thing which we called as default subnet mask. So how we calculate subnet mask? So let's say in any IP address, when all the network bits, so for example, let's say when I'm saying 111.1.1.1. So I mean, by looking at this, you can easily say this falls under this particular range. Yeah. So this is basically a class A IP. Yeah. So how basically a subnet mask is calculated? I mean, all the bits in the network portion are converted to 1. So basically, if I need to put it in a decimal format, this basically would be like 0.000000001, and likewise for these two. Yeah. And then for, let's say I'm writing all as 0, and then we'll calculate that what is gonna make 111. So let's say 1 2 4 8 16 32 64 and 128. So 111. So basically 1 is 64, 32, so 96, and then 16, that would be 112. So that is not gonna be. And then 0, and then which one? 1 0.
Sir, I think 16 will not come.
16 is not there, right? So
Yes,
that
sir.
is what 16 will not. 16 is not there. So you see, this is 128, which is 0. 64 is 1. 32 is 1. 16 is 0. 8. I mean, if you calculate like 64 plus 32 plus 4 plus 2 plus 2 plus 1. Yeah. Right. 96 plus.
Yes, sir.
7. So like this. I mean, we had. Now it's fine. Right. So how does we determine the subnet mask? Basically what I wanted to show you is this is the network side. I mean, these are the network bits and these are the host bits. So all the network bits are actually written as 1111. Yeah. And all the host bits are written as 0000. So all zeros are commandly written as 0. So what it will be basically a /8. Okay, because these are the 8 bits, these are the first 8 bits, 1 to 8. Yeah. So for any class address, I mean, this is how we write, or how we write is it as when you add this all up, I mean, from 128 until 1, the sum is 120 or 255, and then the 2 0.0.0.0. Okay, but in CIDR or VLSM note kind of stuff, we actually write it as, I mean, when you will come to know about the variable and subnet mask, then we follow this kind of uh, /8 or /16 or /14. We'll talk about it. And similarly in class B, what happens is, let's say again 8 places of network bits. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. .x 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 .x. So what happened in class A? This bit was reserved as 0. So that is how my router or computer or any machine is recognizing it as class A address, right? So and the bits which were available was 7 bits. Yeah. But what happens in class B? These 2 bits are reserved. So the first bit would be as 1 and the second would be as 0. And how many bits are remaining? Are 6. Yeah. So these are the places where I can change. I mean, that would be the number of permutation or combinations to get the network addresses. So 2 to the power 6 basically. Yeah. And these are the number of network addresses that can be there. So for example, I mean, even again, if we again talk about class A, what we talked is, I mean, this is how we got our first address, not usable, and then 0 0 0 0 0 1, the very first. Then what could be the next? 0 0 0 0 0. Okay. 1 0. Yeah. So this is your second network address. What this is? This was 1 and this 2, right? This is on the second place. And then 0 0 0 0 1 1, which is 3. Then we come to 4. Yeah. Then we come to 5. You're getting it? 6, 7, and then the fourth place, 8, likewise. So what we did is 0 to 127, but then these were not included. So 1 to 126. Now, similarly, for class B, how it's going to be? I mean, starting from here, yeah. So this is 1, and this is 128. You're getting it? Hello? So this is 128. I mean, this would be 0 in the very first place, right? So this is 128. Then the second would be 1 0 0 0 0 0 0 1. So again 129. Let me clear it up. 1 0 reserved. Then 6 different places. .x, .x, .x. These are your host bits. These are your network bits. Yeah. So the very first would be, and again, let me write it again, 16, 32, 64, and 128. So what is going to be the first address? This is the only one, and rest are 0 in it. Yeah. So the first address is going to be 128.x.x.x. Yeah. The second address, this place can be 1, right? Then 128 plus 1 is 129.x.x.x. Very great, man. And then this could be 1. This could be 0. So 130. And what could be the last scenario? 1 0 1 1 1 1 1 6 7 8. So what would be the total? If you calculate it, it would be 191, right?
Yes.
So the range for class B then is 128.0.0.0 to 191 dot
0,
what?
0, 0.
256.
256 or
Dot 256.
255?
255. 255. 255.
How it's gonna be 255?
So it's up to the end. 190 up to 192 except 190.
Correct. I mean, I don't know if others are getting this or not, but I mean, you're pretty sure. I mean, how this 191 came, but how we are getting 255 in the second octet? Can anybody else explain it? I mean, then only I'll come to know that you're getting it actually.
As all the calculations of the 2 raised to power calculation will be 255.
No.
So in each octet there will be 255. 250.
Correct.
So suppose it's from 0 to like it will be like ascending to descending.
No, I mean,
0 to
I'm not sure what you're
255.
trying to say actually.
In every octet from 191, so it would be 191.0.0.012 to 190.0.
Okay, let me write it again. Let me write it again. Okay. So this is our first 8 bits of the octet. Okay. The first one was what? 1 0 0 0 0 0 0 and 0. Okay. So these two were reserved. But what you didn't tell me, or what anybody did not say in the beginning, that in class B, these are not the host bits. These are the host bits, and these are the network bits. So nobody could explain that how this 255 came, because this is the octet from where we got the 255. Getting my point? Again, what I showed you, I mean, not even class B, class A, network dot host dot host dot host. What was class B? The two octets were
Network dot network dot host dot host dot
and these were your network bits, and these were your host bits. Class C.
network
Network dot host.
And then this is again network, and the last octet is for the host. Now talking about class B, when I said 2 octets, so this is like this. Okay. And in the very first octet, let's talk about the first octet. These two were reserved. So that is how your a router or any device is getting that this is a class B, because 128. Yeah, the very first is 128. It's on the 128th place. But what would be the combinations? I mean, if I further expand it, how it's gonna be? It could be 128 considering this, and then the permutation and combinations. This could be 1. Let me open these up as well. 1 2 3 4 5 6 7 8, and then your host bits. Okay. So for first octet, what we did is, in the very first octet, let's say everything was 0. All the bits, all the network bits were having 0 in this place. Sorry. Yeah. Okay, so what this became 128.0.x.x, and considering this is a network address, so all the host bits are also 0. So this would be your very first network address in the class B, right?
Right.
Now, what could be the next thing? I mean, which particular octet we can try?
129.
Correct. 129, and how it will be 129? We are continuing in this octet only. Yeah. So we are not touching this octet at the moment. So 1 0 0 0 0 0 0 1, right? And the
Yes,
rest
sir.
are 0.0. So this becomes your 129. And likewise, once you are done with this octet, this will become 191, right? After all are 1
Yes, sir.
in this particular octet. Then we'll
Yes,
move
sir.
to this particular octet. Yeah. One could be here, then then 10, then 110, then 111, then 1110, right? And after alls are 1, that would be the highest network,
255.
I would say, like 1011, all these are ones. So this becomes 191, this becomes
Dot.
255, this becomes 0.0. Yeah.
Yes, sir.
So these could be your this is the basically what you can say is the range. Okay.
Range of class B.
Yeah, so 191, sorry, 128.0.0.0 and until
191.
191.255.
255.0.0.
Yeah, so there are two things. I mean, okay, maybe we'll talk about after class C. I mean, we need to know. I mean, this is the range, but then there would be two things in it. One would be your network address that will basically define let's say any IP out of this particular range, let's say 128.11.10.32, and there would be a subnet mask. So you could be asked, or you can ask, or you if you need to know that what is the network address of this particular IP, then how you will calculate the network address? Yeah, Ankit, go ahead.
Sir, my concept of network and host bit is clear, but you have reserved the first bit and the second bit, like we have reserved 0 for class A in the first octet, first bit, and in the class B we have reserved 1. Then if all the in the first octet, if all the ones are there, then the range will exceed.
No, don't consider these two, right? The number of bits, how many number of bits you have? Then 6 here, and how many here? 8. Okay, so how many networks bits you have? 14.
Okay, we have to skip these two for class B.
Class B, this is reserved. You cannot do anything. Class B means the very first two octets are 1, and I mean the very first two places are 1 and 0. These are not going to get changed.
Okay, sir.
Okay, this
Now
is
it's
not,
clear.
I mean, this is you can say this is the architecture, or this is how it is. And I mean, how your machine or how your operating system understand it. So whenever let's say whenever this technology is defined, it's sort of, I mean, let's say for your computer to understand, this is embedded in the code, right? If in the very first two places, if this is the setting, then this is a class B address. If you change it, how your machine will understand it. So this is how to make it understandable to the routers or to machines. This is how you define it. Like I said, in the class A, the very first octet is 0. In the class B, it's 1 0. We'll talk about what happens in class C. Okay.
Okay, sir.
Now you got it. You still have any question?
Not now, sir.
Okay. So this is class B. Now let's talk about one more thing. Then we talk about class C. I mean, I told you about the IP addresses, network part and host part. So let's say, for example, this is the let's say I'm saying 128.11.1.1. So how do I come to know that? Let's say there are a few questions for you, that what is the network address of this particular IP? Okay, and let's say what is the broadcast address for this IP? So how we calculate, actually, I mean, if you see 128 and if you know the range, then it belongs to class B. Yeah, class B means 255.255.0.0. Okay, so actually how you calculate the network address, I mean, from a mathematics perspective, it would be like, when you open up the 128, so it's like 1 0 0 0 0, okay, and 0 0 dot, then 11, let's say 0 0 0 0, and 164, and then one second, then this would be 1 and 0 1 1, and then 0 0 0 0. I mean, this should be clear to everyone, because I did not teach you decimal to binary or binary to decimal, but it's pretty straightforward, right? I mean, you know all this placing. What I mean is, like 1 2 4 8 16 32 64 and 128. So how this one is calculated? When all these places are 0 and this is only 1. So that is how it becomes 1, and then this is 1 plus 2 and plus 8, 11, and this is 128. So 128. Now 255, what we're gonna do is, what is 255 if all the places are 1? Yeah, and then this is 0 0 0 0, or I mean, this is just to show you how this mathematics is done. Otherwise, I mean, you can tell it straightforward that it's a class B. And so, I mean, if you know this AND operation, so 0 and 0 is 0, and 1 and 0 is what? What is 1 0 AND operation? No. Okay, nobody knows it. All right, it's 0 actually. And what is 0 0 and what is 1 0? Again 0. So all are 0. This all are 0. And what is here? 1 plus 1 would be 1. 1 0 would be 0. So again, this is going to be same. So basically, I mean, if it's class B, we know that this is class B. So if I do, I mean, even if I do 255 into this, again, this is gonna be 1, and then rest gonna be 0, right? So this is gonna be 128, and then this is 11, again the 1, and this it's gonna be 11, and then the rest are gonna be 0. So I mean, this is how the mathematics is done, but you could have said in the very first place, considering it's class B, so it's a straightforward 128.11.0.0, and that is the network address. And what could be the host address? What would be the, sorry, broadcast address? When all the host bits are 1. So basically, when all the host bits are 0, that is what we called as network address. But when all the host bits are 1, then it becomes the broadcast address. So I mean, you can use that particular address to broadcast among that network. That you will understand later, that how this broadcast happens. So what would be the broadcast address? 128.11.255.255. So what is the network address for this particular IP? 128.11.0.0. And what is the broadcast address? 128.11.255.255. Now comes another question. Then let's say this is this is the IP, and we got to know that this is the network address. So how many number of IPs would be usable in this network network address? So for example, if we say that let's say for example class A or let's say class B only, because we are talking about class B at the moment. So how many number of network bits are there in class B? Again 16, right? 8 plus 8, first two octets, right? And the remaining host bits are 8 plus 8, so again 16. So what would be the number of hosts which are available? Combination of 0 and 1. So two particular combination which are available. So anyone, what could be the number of host IPs?
So 2 raised to power 16.
2 to the power 16. But these two IPs can't be used. One is network address and another one is broadcast address. So the usable number of IPs would be 2 to the power 16 minus 2, or 2 to the power n minus 2, where n is nothing but your host bits. Okay, so this is the scenario. I mean, if somebody asks you that what are the number of IPs in this network, or rather usable IPs, then these are the IPs which are available. Okay. So yeah, so I mean, this is how maybe another example for let's say 11.10. 11.11, then what is the network address? Now it's very straightforward. Anybody can answer this. What is the broadcast address? Because you know what is class A. Yeah, so you don't need to do that AND operation, but I think people from electronics and communication background should have answered that how we did that AND operation. It's pretty straightforward. And the number of usable hosts or IPs. Yeah. So what is the network address for this particular IP?
11.0.0.0.
Yeah,
or you can write it as /8. I mean /8, or 255 or 255.0. So what we call it as default subnet mask. Why? Because we are talking about at the moment, I think I told you, we are talking about classful subnetting. Yeah, this is predefined. I mean, this is early age. Yeah, when things were not that big on the internet or in the world, when all this technology were getting defined. So this is the beginning. So this is, and then what is the broadcast address? 11.255, all the host bits are 1. So this is the broadcast address, and then again 2 to the power 220, 2 to the power 24 minus 2 would be your usable IPs. Okay. So default why we call it default subnet mask? Because I mean, in class A, we know that 8 bits are network bits. We are not borrowing or giving somewhere. So this is by default. By default, whatever this set up in, I'm sorry. This is not 255. I mean, usually it's a practice of writing. So even I'm saying /8, I'm writing /24. So default subnet mask, because this is the default setting of class A. So that is why we call it as default subnet mask. Yeah. A similar scenario, I mean, you can do all this calculation yourself for class B or class C. So now let's talk about class C. Okay. So what happens in class C? Can anybody tell that what is the range for class C and how we determine it?
192.0.0.0 to
Yeah.
223.0.0.
223.255.255. Correct.
If I'm not wrong.
Correct. And how do we determine it? And this is
for class C. First octet we reserve the first 2 bits as 1 1, and the
So
rest
first,
all are zeros.
correct. Not all. I mean that, right. I mean that is how it is. So what we do is, let's open up the first octet. How your router or any machine understands it is the first two bits are kept as 1 1.
1
Okay.
1.
So what was in class A? The first octet was, I mean the first bit was 0. In class B,
0.
1 0. In class C, it's
1
1
1 0.
1 0. I mean 1 1. Yeah. 1 1 or 1 1 0?
110, sir. 110, sir.
Okay. Let's see if this is the scenario or not. So let's say others are also 0. Okay. Now we are doing that calculation. So 128 and 64. What became? It became your 192. Okay. Now the next IP. What could be the combination? Because you remember these three are your network bits, right? And this is your host. The last octet is your host. So the number of bits in class C, 24 bits are network bits. And 8 bits are host bits, right?
Host bits.
Yeah.
Right.
So let's expand the first 3 octet of network bits, then you will understand it better. So 110. Okay. This is 255. Considering, let's say, we are going on. I mean, this was the first address 192, and considering these two were 00, right? The second and third octet. Now we are talking about the last octet. So somebody said this is 110. So let's calculate if it's really 110 or it's 11. Okay. Because it is 223. I mean, you can clearly tell, but still calculate it. So let's say these are all would be 1, right?
1. Right.
So this is 255.255. Yeah. And then the host part, considering it as 0. So this is 0. Maybe this should be like this. Now this is 1, this is 1, this is 1, this is 1, and this is 1. And this was 1, and this was 1. Now calculate it.
1 0.
If you remove the 632 out of 255.
Sir, it's 2 to 3.
2 to 3.
2 to 3.
2 to 3, right? If this was not the scenario, then what would have happened? It would have become 255. So what is the scenario for class C? Got the point? So this is 0. The 3 bits are reserved. Class A 0, class B 10, class C 110. Okay. So that is where we cannot change this particular bit. This will always be a 0 place in the first octet of network bits for class C. That is where out of 255, if you remove this 32, then only you will come to know this is 223. Got it? So what is the range? 192.0.0 to 223.255.255.0. All right. So what is the network address? I mean, it's straightforward, you can say. It's written here only. What is the network address for class A?
Class A?
Sorry, class C.
It's the 192.255. 192.0.0.
Seriously? I am asking network address.
192.255.255.0.
Correct. So what is network address? When all the network bits are 1 and the host bits are 0, that is what the network address is, right? Or what we did, the IP plus subnet mask. For example, this was the IP, right? 11.11.11.11. 10.11.11 and the subnet mask was /8 or maybe 255.0.0.
This
So,
is first class
so,
class
so
A address.
yeah, class A address, right? This is the example of class A address. Again, I'm telling you, or /8 or 255.0.0. So what is this? This is the IP address, right? And this is the subnet mask, or
Right.
at the moment, this is the default subnet mask. So what is the network address from a mathematical formula? Network address is nothing but IP plus subnet mask.
Host.
I mean, for mathematics, and operation of IP and subnet mask, right? I mean, if you convert this into binary and then you convert this into binary and then do an AND operation, 1 0 is 0, 0 0 is 0, 1 1 is 0.
Zero.
I mean, if you know that
One.
rest of the bits are 0 in the subnet mask of class A, whatever is here doesn't matter because these two combination are going to make it 0 only, right? So whatever the
Right.
ones places here in the first octet and the ones places matching this ones places in the subnet mask will be 1. So you can straightforward say that this is 11.0.0 is the network address of this particular IP. I mean, you don't need to do this mathematics, but I mean, this is how you are doing, but then how your, how, how your router understands it. So basically it's doing an AND operation between your IP and subnet mask. That is how it is determining your network address, that you belong to this network address. Okay. Because when you would be doing subnetting, let's say this is a subnet, this is, I should not say subnet, let's say this is a network. And when we do subnetting, so what is subnetting? We'll talk about it later also. So basically when you break a network into a group of networks, subnets. So let's say if you break this, let's say this is your, what you can say, it's a plot size, yeah, your house. This is your boundary wall, and then you have your house built and different rooms are there. So how how you recognize this boundary when you are entering this, what you need to recognize is this address, that this is where the packet needs to be delivered. But then when I told you, remember in the LAN I gave you the example of, I gave you the post office example, then how it actually delivers, whether it's, there are, let's say, 4 different people in this room, then this letter belongs to which guy. So that again gets determined by your subnet. Okay, so that is where, let's say it has come here, but it is a broader network. You'll understand it better when we'll do more subnetting or more routing practical. On a broader routing level, nobody understands these rooms. Everybody would be understanding that this is the place where this needs to be get delivered. But when it lands here, then how it will determine that this belongs to whom? So that is where your router does this AND operation, and then it will determine whether this packet is a part of this subnet of the bigger network, or it is a part of this subnet of the bigger network. So when we will do subnetting, then you will understand that this is the bigger address, but then when we are breaking it into 2 subnet or 3 subnet or 4 subnets, which subnet it needs to go to. Okay, so this you will understand better there. All right, and then class D, it's a multicast. Yeah, what is the range?
So 224 to 239.
239.255.255, or maybe let's say this is the 255. The last address, broadcast address, you can say. But this is again, these are the broadcast range of IPs. You don't assign them anywhere. So when we will be learning about the dynamic routing protocol, at that time you will come to know that you will see some of the broadcast address from this range assigned to some of the dynamic routing protocols. That is where we're going to use them. Okay, so and class E, so okay, from the reservation perspective, and what I mean by reservation is, how does your machine understand that it's a class D address? So I think now it's pretty straightforward, right? 128 64 32. How much? 2 to 4.
Yes, sir.
And then this is 0. So these 4 bits are reserved in this. And in class E, I mean, it's self-explanatory, but you will never see class E anywhere. And even, I mean, you won't see this. I mean, this is older stuff. I mean, this classful subnetting. This is again, I mean, like I said, I mean, this is when the internet was, in its early stage. When, I mean, today every device needs an IP address. I mean, it's a world of IoT devices, right? So all the devices are connected via IP. So that is where the IP shortage started happening. Then they came up with the concepts like netting, and then how this variable length subnet mask or classless, a CIDR concept came in. So that's what we'll come to know. But then this is the uh, generic classification, and on a broader level, or this is how your machines understand, uh, you know, that which particular class it belonged to. But why do we need to do? I mean, if we talk about subnet, or maybe we'll let me come to the PPT. Then we'll talk about that. Why do we need subnetting? I mean, what you understood at the moment is different classes, but then you also need to understand that why I mean, how these host bits are coming in picture. I mean, so basically, I mean, what we are seeing at the moment is, you can say, top to bottom approach. Basically, what we are seeing is how it's defined. But when it comes to the real application part, then you will see a maybe bottom to top approach. I mean, now we are talking about the network bits and host bits, but how the requirement comes in, that I need these many number of hosts, I need these many number of IPs. So that way, I mean, you utilize all those techniques. Because I mean, at the moment, let's say 8 bits, right? So let's say 2 to the power 1 was reserved 7. So these are the number of networks. Okay, but let's say one address of class A is 60.64.0.0.0. So how many IPs I can use? I can use 2 to the power 24 minus 2. So in this IP address range, these number of the IP addresses which are available. But do I need really these number of IPs? I mean, there would be a wastage of IP. A lot of IP would be wastage. So I mean, what happened? I mean, initially, what INA, the body who manages all this, I mean, the initial class A IP, some of these IPs are assigned. I mean, you can Google about the INA and ICANN. Some of the ranges are actually divided into some of the ISPs, that this range belong to this IP, and then sorry, this ISP, and then those ISPs will do a further subnetting, and they assign it to different organizations or clients. But some of the IPs are also assigned to very large organizations. For example, I think you might see Google also have some of the addresses assigned from class A. So that is, I mean, that is the background. I mean, this is the regulating body. Then they come up to class A, and then they further do subnetting. That is how the whole structure is. So I mean, if you Google about how internet IP addressing or about the INA, you will come to know about that, how this is defined. So what we talked about is at the moment is uh, IP address, and what are the different classes, and what we talked about is basically public IP address range. So in class A, class B, there was another thing which we need to discuss. I mean, we discussed very brief, yesterday, but we will talk, and that what is the, for example, in class A, there's a private range of IP addresses defined, which you cannot use. I mean, they are not routable. So 10.0.0.0 to 255.0.00. So basically 10.0.0/8 is a private range of IPs, which is which is used in your LAN or in your enterprise network. In your LAN, I mean, enterprise network uses both your private plus public, but then this is not routable on the internet. We'll come to know how. And then what is in class B? Private range of IP 172.16.0.0 to 172.31.0.0. So this is /16. And what is there in class C? Then anybody knows class C private range of IP?
192.168.0.0.
It's everywhere in our home routers, right? By default, I mean it's 192.168.0.0 to 192.68 168.255.0 /24. Yeah. So these are the, I mean, there is something called as RFC. I don't remember the RFC number for it. So you can Google that what is RFC. Every technology has a RFC number assigned for it. For example, I don't recall the RFC for private and public range of IP. So this is request for comment. There are, a few bodies who work together. So this is, you can say, kind of, I should not say blueprint, but I mean, this is the technology document around any technology. There are bodies, who prepare this document. So there is a IRFC number for almost every, for all the technologies. So there is a RFC number defined for private range of IPs, where a structure is defined, that this is how it is defined in that RFC, that this is how the technology is, this is how it should be implemented. But it's never like that how it's defined in RFC and it will be implemented 100% like that. I mean, that varies at time to time. But I mean, you can Google yourself that what is RFC. I mean, at CCNA level, nobody talks RFC. But yeah, I mean, it came to my mind, so you can Google that what is in RFC. Yeah. Okay. Talking about, we talked about host addresses, okay, CIDR, it's early, I guess. All right. Or maybe to give you a little more understanding, 1-2 questions around this exercise, maybe. No need to speak up. You can do at your level. Okay. Otherwise, it would be just a theory. For all these three, you can do. I mean, I'm giving you 5 minutes and I'll be back in 5 minutes. I'm gonna pause the recording. You can, very quickly just to, all right. So class A subnetting. So this is again when we are saying class A, class B, and class C, what we are saying by default is classful. Yeah. Okay. So this is predefined stuff, default stuff. Yeah. So I mean classful. So this is default grouping. So for example, let's say I have an address 10.0.0.0. It's a class A address, right? Class A. So what would be the subnet mask for this, or other default subnet mask, because this is classful. So let's say default subnet mask. Yeah, 255.0.0.0. So what would be the number of network bits? 10.0.0.0.0. Network bits are 8, right? And host bits are 24, right? I mean, that should be pretty straight, right? Network bits are 8. That's what happens in class A, and host bits are 24. Yeah, and subnet mask is what? All bits are 1. So that is how we get 255, and remaining are 0. Okay. Now what I need to do is I need to break this address into 2 addresses, let's say. I mean, in 2 subnets. So this is, let's say, this address, which is 10.0.0.0, and I need to break it into 2 halves. Okay. So So and these are what we call it as network bit. Yeah, here. I mean, I'm again repeating it. And these are host bits, right? So what we're gonna do is how we're gonna break it into two. So whenever we do subnetting, we never touch host bits. We never touch network bits. What I mean is, for example, let's break this 10 into binary format. So 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, and I'm gonna keep them as 0.0. So 10, right? So 10, this would be 0, this would be 1. Again, this is what? This is 4. So this is gonna be 0, this is 8, 1, and so this is how it become 10, right? 1, 2, 4, 8. 8 plus 2 is 10, right? This should not be a problem. So in subnetting, we never touch this network bits. Whenever we are breaking this network, we are never going to touch this. We are not going to change anything. Why? See, this is your house address. What you are going to do is you are going to make rooms within your house, right? You're making rooms within this plot size. Yeah, you're making different rooms. At the moment, we are going to break it into two. Okay. So if we do anything on the network part, in the network bits, what will happen? We are actually changing this address, this network address, this house address we are going to change. So how everybody on the network or internet will recognize this address? Then this would be somebody else if I change the network bits, right? Getting my point? Yeah. So I mean, if we change this, then this would be something else. This won't be 10. This might be 11, 12, or whatever kind of change we make. Okay. So this is not gonna be, there won't be any change on the network bits. So whenever we do any partition or any subnetting, we always deal with host bits. I mean, we make changes in the host bits. Okay. So what we wanna do is we will reserve this. Okay, so we are gonna borrow one bit from the host bit. Okay, so what could be? So let's say when we borrow, we go right to left. Okay, we borrow from this side. Getting my point? I mean, until the network address is, then we borrow from this side. So we are borrowing this one bit. We are actually including it in network bits. So if let's say this is, we have borrowed this bit, and the very first place or the very first value we can put here as 0. So what is going to be the first address? So the number of network bits now, how many number of network bits are there?
9.
9. So what would be the subnet mask?
255.128.0.0.
00.
So what would be the first address? What would be the network address of, let's say, this particular new address? Let's say this is this side. What is going to be network address along with subnet mask? 10.0.0.0, of course, yeah, it's /9, right?
/9, right.
Or 255.255.128 .0.0, right? So the bigger chunk was 10.0.0.0, and the default subnet mask is, this. Then we did a partition. The one bit which we got is 10.0.0.0. Subnet mask of that particular portion is this. And what would be the next subnet? So we will change this 0 to 1. Okay. So what would be the next network?
10.1.
No, 10.128. When
128.
this is 1,
Yes.
right? This is 128th place of second octet.
Okay.
0.0.
0.0. Yes.
Yeah. And then what would be the subnet mask?
255 dot. 255.128.0.
255.128.0.0.
Yes.
Is it? So what would be the first IP? What would be the first IP of this network? Of this
First IP
network?
is
10.0.1.
10.0.0.1.
Yes. And what would be the last IP?
10 dot.
Yeah.
10 dot. 255 dot. 255
Sorry,
dot.
come again, 10 dot.
255 dot.
Okay, 255 dot.
255 dot. 255.
Are you sure?
No. It's 128.2.
The last is the last is 254.
Not 254. We have borrowed this
128.
particular. We have reserved this
Oh,
one. So the
yes.
remaining are
Okay.
127.
Yes.
So 255 minus 128 equals to 127. So the last IP would be 10.127.255.255.
Okay.
Got it?
Yes. Thanks.
Yeah, and in this particular network, what it's gonna be in the second subnet in this half, the first IP 10 dot
127 dot.
not 127, 128.
128.
We made it one, right?
Okay. 128.0.0.
0.1. I'm talking about the IP.
Okay. 0.1.
And what is the last IP?
10.128.255.2.
Come again. What is the last IP?
128 dot.
Huh?
255.255.
Acha. So what you did is you considered all 0 here. But that won't be the scenario. These are the host IPs. So what would be the last IP? So all the host IPs are 1. So these are also become 1. So when they become 1, this is 127 and this is 128. So the last IP would be 10.255.255.255/9 or 255.128.0.0. Is it clear or not?
Okay, it's clear.
Guys, I hope you're not. Yeah, I mean, it's clear to you. I'm not sure about others. I hope everybody got it.
Clear.
Okay, or maybe we can, let's repeat this again. Let's say what was the address, whatever it was. This is the bigger chunk. Okay, now we are breaking it into 2. And what was the default subnet mask? This was the default subnet mask. What we did is, I'm repeating because I'm pretty sure that many of you might not, understood it. So again, 0.0. Okay. So what I'm doing is, like I said, we don't change anything on the network bits whenever we do subnetting. We are not changing address of this house. We are doing internal changes. So there is no change. The network address means this identity of this place. So I'm not going to touch it. If I touch it, this would be a different place. It won't be this guy. It won't be this address, right? So when I say subnetting, I'm making rooms rather than changing the house. I'm making rooms within my house. So what I did is we always go left to right when we need to borrow, the network bits from the host bits. We borrowed this. So the total number of host bits remaining 23. Yeah. And now the host bits are, the network bits are 9. So 23 plus 9 is 32. That is what our IP address is, right? 32 bit long. So these were reserves. These were the places. Now what I did, the very first thing, I'm not going to make any changes here. What I can do on this places, there are 2 possibilities what we can do. Binary possibilities 0 and 1. So in the first place, I kept it as 0. So when it's 0, it's gonna be 0 only. This is gonna be 10.0.0.0. But then this is part of network bit now. So what the number of network bits are 9. So /9 or 255.128.0.0, right? The first IP would be
10.0.0.1.
correct? Now when we talk about the first IP, we always go from right to left from the host IPs. When we talk about network bits, we always come from left to right. When we talk
Left
about
to right.
host, we go right to left. Yeah. So the very first 0 from here, we made it 1. So that is our first IP. Now what we did for the last IP, these all are 1, these all are 1, but this one remains 0. So 10 dot, the 0 means 128. Yeah, this is on the 128th place, right? So I am not making it 1. So if these remainings are 1, which becomes 127.
127.
So 127 dot 255.255. This is the last IP. Yeah. Similarly,
Last usable ID will be.
I mean, this happened for this particular area. Now, let's say for this area, what we did is we made it as this 0 as 1. So this became 128 actually. So 128 would be the 10 dot. What would be the first IP? 10.128.
10.128 0.1.
And what would be the last IP? All become 1. So 128, and then these 7 becomes 1. So 255. And the remaining 2 octets of course gonna be 255. And the subnet mask would be /9 or 255.128.0.0. Yeah. So I mean, this is how we do subnetting. Likewise we will do for class B. Let's take an example of class B. Any address from the class B range? What was the class B range?
172.16.0.2.
No, this is the example. What is the range I'm asking?
Okay.
192.
191. 191.255.255.255.
This is again the last. I mean, you tell me and then you tell me the range. I mean, 191 dot. What in the next 3 octets? The network address.
0.0.
What would be the last one?
191.255.255.
I'm asking the last address of this range, the last network address. What is the class B range address?
Okay, sorry, sir.
Guys, no rush. I mean, you can think. I mean, I don't know if you're taking notes or not.
Bits and 2 host bits in class B.
Sorry?
There are 2 network bit and 2 host bits in class B.
Correct. Network. Class B is what? Network, host. Okay. 1 0. The first octet, 1 0, right? So 1 0 means what? 128 plus 64. What does it denote? 192. So my class. So my class A will start from where?
192 dot.
Really? 192?
No. It would be the class C address.
Correct. So 1 0, when I make it 1 0, what this address becomes? 128. You're still not getting it.
Right.
First octet. Right. And then second octet is also network. Then the remaining 2 octets are host. What was the reservation of these 2 bits? 1 0.
1 0.
And let's say that all are zeros. Yeah. So this one means 128. And then all are zeros. So means 0.0.0. What is the first address?
128.0.0.1. It is the first usable address.
That is first usable address. Correct.
Yeah.
But I'm talking about the range. We are talking about the range, right?
Right.
So this would be the first type. This would be the first network address. And what would be the last?
191.255.255.255.
How it's 191.255.255? Not 255. These would be 0. These are host bits. 2 octets. How can you say anything about the last 2 octets? Whatever is going to happen, it is going to happen between these 16 bits, right?
Yeah, right.
So how it's 191?
In first octet, 110 is reserved for network bit.
Correct. If 10 is reserved for class B, we know. Then how did it become 191? Guys, please use your brain, whatever I have taught you. It's pretty easy. This is reserved, right? This is reserved, which means there is nothing going to happen on these places. What is going to happen is on the remaining 6 places, right? So in the last address, what will happen on the remaining 6 places? All will become 1, right?
Sir, 1.
So remove this 64 out of 255 because this will stay 0. This cannot be 1, right? This place is fixed. But this one and the remaining one, the only one is 0 here. Guys, if you are speaking, please go on mute. Please stay on mute if you are not speaking, or if you don't have anything to ask or answer, please stay on mute. So 128 and then remaining, and this place is actually 64, but the total of everything is 255, right? So minus 64 is what? What? 191, come on. 255 minus 64 is 191, right?
Yes.
And this octet will become again 111, the second octet. So what would be it?
191.0.0. 0.0.
Correct?
And yes. So if it is 192, it's gonna become class C.
Class C, correct. So let's take an example from class B for subnetting. Okay. So I mean, I just redid the class B for you. But anyway, I hope you guys are taking your notes. So let's say there is one address from class B, for example, let's say 154 dot let's say 250.112.120. So again, what is the network address for this IP?
754.250.000.
Perfect. And the broadcast address, so this is network address, yeah. And the broadcast address, again, it's
154.250.255.255.
all right. So let's say now this is the subnet and I'm gonna do a partition in it. Okay. So class B is this. What does it mean? Network and host. So we are not going to make any changes in the first 16-bit. We cannot. This is our network address. We cannot change our identity. What we are doing within partition, I mean within this space, we are going to make changes. So what we're going to do is, let's say this is the first octet to borrow stuff from. Yeah, Vishnu, please stay on mute if you're not answering or asking anything. So 1 2 3 4 5 6 7 8. So what we're gonna do is we're gonna borrow first bit. Yeah, and what was the subnet mask here? /16, right? Or 255.255.0.0. Correct? So this is /16. Now we are not going to change anything. We are not gonna change anything, like I said earlier, in these first 16 bits. So we are gonna make a difference, or we're gonna borrow the 17th bit from the left to right. So what will happen? 154.250, this is gonna stay as it is. We are not making any change. This is representing our network, the network address, right? The change what we're gonna do is here. So when we reserve first bit, which we will keep it as 0, and what is this place? This place is 128, right? So the first address is gonna be 128.0, and then how many bits? 8, and we borrowed 1, so /17, right? Yeah. And what would be the second subnet? What would be the second subnet?
Sir,
154.250.250.
No, this is not like that. This how it will be to 128 here. When I said, I mean, you guys don't even highlight the mistake what I'm making.
So it's 154.251.
When it stays 0, which means it will be 0, but because this
Yes,
has
sir.
become the network bit, so network bit has increased from 16 to 16 plus 1, 17. So the address has become 154.250.0.0/17. Yeah. And the next one would be when we
251.
make it as 1. This is 0 portion. When I change this bit to 0, then that became this particular side. But when I make it 1, then it would be this particular side. So what it's gonna be is 154.250.120, right? .0/17. Got it? Or any confusion?
But I'm confused. Why the /7? That's my confusion.
Why it's
Yes.
/17? Why it's
Yes, yes.
/17? So how many network bits are there in class B? 16, right? 8 plus 8.
Okay. I got. Thanks.
Yeah.
Okay.
So now we borrowed another host bit into the network portion. So that is where it became 17. But this particular block starts from, so the range for this particular block starts from 154.250.0.0/17. So this is network address. What would be the first address? For host IPs, we start from last octet, right? From
Yes, sir.
right to left. So if we make it as 00000, let's say this is last octet, for example. So first place is 1, then the usable first IP is 1. What would be the last? So if this all become 1, this second octet become 1, 255.255. Yeah. But the subnet is /17. So okay, we talked about one formula in the beginning. So when we are writing /17, it looks fine. But then did you remember that I told you in the beginning that let's say packet is coming to one particular let's say packet is reaching one destination, which is let's say 154.250.250 dot let's say 252. This comes under this range, under this particular portion of my address, my first subnet. Yeah. So how, when it reaches here, it reaches this address, which was this address. This outer boundary is what? 154.250.0.0/16, right? But when it reaches, but it is destined to this particular address, and this is what? /17. You're getting my point, what I'm asking? Yeah. But when it actually reaches, let's say packet came here and then it reaches to my boundary, then how it will determine whether it's going to be this room or this room? So the mathematical formula which we were talking about earlier, so if you see 154 is what? Shall I erase? Let's see it from that formula. Then you'll understand that what was the meaning of that formula.
So I have a question.
Yeah, go ahead.
Sir, like if we are doing classless, then we earlier have /16. Then we have network bit of 16 binary digits of first and second octet. First octet 8 bits, and second octet 8 bits, and third octet first bit.
Correct.
So, sir, while we are dividing that network, then after the 16th bit, like
it will not
17
be.
bit.
So I got your question. What you're trying to say here is that in class B, we say 8 plus 8 network and 8 plus 8 host. But when we borrow something from here, the class B definition says 16 network bits. But if we are borrowing something, then how it still can be class B. That's what you're saying.
No, sir. I am asking about the host network from this subnetting. Like we are declaring that in the /17, first subnet will get .0.0, and second network will get 1.0. So
not 1.0, but 120.128.0.
Okay, sir. I got it.
Got it? What we did, again, network bits are unchanged. This is my third octet. Okay. the host octet 1, 2, 3, 4, 5, 6, 7, 8. Guys, if you are not getting it, you can ask. No problem. We can repeat it. So what we are doing is left to right. We are borrowing this bit, this host bit for the partition. So this host bit we have borrowed, and there are two only combination here available. One is it can be 0 or it can be 1.
So can you write 128, 64, 32 like that so they can understand?
Yeah, I'm going to write it. I'm going to write it that way. So this is 128, 64, 32, 16, 8, 4, 2, 1, right? So what we did is we borrowed this place. Now one place is 0 is this place, 1 is this place. So when I borrowed this place, when I borrowed this block, we divided it into 2. Then what could be the one thing? So we are actually determining. I did not tell you there is another way of teaching this using block size, but that is confusing. I mean, so what we can do on this place is this place can stay as 0, for example, but this is a network bit now. So the number of network bits now are 9, and the number of host bits are now 23. Correct? So this could be 0. So if it is 0 and remaining are 0, then what would be the address? 154.250 dot, because this is still 0. So this will be 0. The total would be 0 because all are 0 at the moment. Correct? And this one in this octet also. So the total becomes 0 and again 0. But what is the network address? How many number of network bits? 9. Sorry, 17. Correct. 1 second.
Yes, sir.
I wrote it wrong. 16 and then plus 1, so 17 and then 15. So it's 17, right? So what happened is 17. So this is 1. Now what would be the last IP in this block? So the first IP would be, if I change it to 1, this first host bit here. So this would be the first IP. And what would be the last IP? The last IP would be, if this
0 and all
stays, this stays as 0 and remaining all stay as 1, which means 127. Correct? I mean 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 would be 127. So the last IP would be 127, because this place is 0, so it cannot be added up. It cannot be added into all these remaining bits, right? And then 255, because all are 1 here. Correct? So what is the block size actually here? So I mean, there is another way of saying it. I mean, if we calculate the block size, but I don't want to teach you that method. I mean, that is a sort of I mean, that's a kind of trick, but then that doesn't help. So yeah, I mean, what is that theory is, I mean, they call it what 256 as magical number. So this magical number, if we which bit we are going to borrow, 128. So this place, if we subtract 128 from 256, that you'll understand that how this 256 comes. And then 128. So the block size is 128, which means the first IPs would be from 0 to what? How many?
250.
How it is 250?
First IP is 127.
127. And then the next IP starts from, so that is the reason I didn't want to tell you about this block size or this magic number concept. I mean, that is another way of teaching it, but go how we are actually doing it, how it actually happens at machine level. So that is a better way of learning it. So this is one block size, and another block size is, I mean, this is, yeah, go ahead.
So you are asking the borrowed network, first borrowed network, right?
First borrowed bit.
Yes.
Correct. We are not talking from block size and stuff. So the borrowed bit can be two things, 0 and 1. Now when I got it, this is my new network address for this block. And when I change it to 1, this is my new network address for this block. So this becomes 128 when I change it to 1, right? And the because this is 1, so this would be 128 and remaining all would be 0. So dot 0. So this is 128, the first address. And then what would be the remaining addresses? I mean, this would be the first address of this octet. Correct? 154.250. 128, because this became 1, remaining all are 0. This particular last bit of the first octet is 1. So the first IP is 1 and the last IP would be all becomes 1. So when they all become 1, the last octet become 255 and the remaining 127 become plus 128 becomes 255. So that is how in this space, how many number of IPs we have from 128.1 till 255.255, and of course these are again the prefixes. Okay, and here what would be the first IP? 1 second, let me complete. 0.255, sorry, 0.1 till 127.255. Yeah, go ahead. Somebody was asking.
So the broadcast will be 127.255.
Correct. Broadcast for this particular address would be this address for this subnet, for this internal room. Okay, and for this internal room it would be 255.255 after this, So okay, now I got your question. So for the bigger thing, before the bigger size, you can say the broadcast address is 154.250.255.255. Correct? For my plot or my house. But for this room also, the broadcast address is 250.255.255. Correct? That is what you're saying, right?
Yes, sir.
I mean, for this room and for the overall house, the broadcast address is same. Yeah, but then there is a subnet mask associated, right?
Yes,
that
sir.
address. That is how it is determining whether it's a /16 or whether it's a /17. Got it? For broadcast address, I need to determine. For broadcast address, I also need to know that what is my network address. Getting my point? See, everything
Yes,
is
sir.
is around the network address. I mean, whenever you say any IP, but then IP is irrelevant to me. If I don't know which network, IP could be anything. How, for example, this is one organization. Let's say this is Google. Okay, and they have a range of IP or they have a subnet. There could be one IP here, but somebody on the internet, how will they determine whether it's a Google or what? They will determine Google by its address, not who is sitting inside Google. Getting my point? So this address is Google, but what is that particular host in that Google would be determined that he's from Google. So what I'm trying to say here is, let's say this is the subnet and this is the IP out of this subnet, let's say /8. Then only you can say, okay, this is the network address, which means Google. What if for this IP I say /18? Then will it be Google? No, it won't be Google. This is a different address. This is /18. I mean, this is a supernet for this subnet, right? I mean, this is a bigger network. This is a subnet. For this network, what is this network? This is a supernet, correct? I mean, if you don't understand the technology, even by English, I mean, this is subnet, this is supernet, right? Bigger network and a smaller network. But in this scenario, if you understand, this might not be Google. I mean, you're getting my point, what I'm trying to say.
Yes, sir.
But this is a different network. And this is a different network. It was /8. This is /18. The whole concept is changed. 8 plus 8, 16. I mean, this then become, this is somewhere we borrowed like 18. We have 18 network bits here, and there we have 8 network bits. You're getting my point? What you were saying is, in that scenario, let's say what was the IP? For example, this was the IP. So for the bigger chunk, for the bigger, for the outer boundary, the broadcast address was 255.255. But when you said that we did a subnetting, we broke it into 2, the subnet, and this was /16. But when we broke it into 2, 154.120.255.255 again is the subnet address of this particular piece, correct? For this second half. But then it is associated with /17. So when you write it like this, how will your machine will determine that this is this, not this? It will do an AND operation, and what it will determine? The network address. And what would be the network address here? 154.120.128.0. Getting my point? Guys,
Sir, if we are considering this 17th bit, then the broadcast address will be same 255. Like it will
correct.
not
This
go to 127.
see, listen, these are the network bits. This is 154, 120, no change. Host bits, we are borrowing 1. We make it as 1. Correct? The second half, this is 1, this is 0. But the last IP is broadcast IP. That is what we know. So the remaining 7 bits in this host bit, they become 1 in this bit. In this octet, they become 1. So this last octet become 255. We all know that, right? Because this network bit in the 128th place, not in the one, I mean, I should not say 128th place, but I mean the place which value of 128 and the remaining are also 1. So this all are 127 plus 128 in a decimal format. It won't be 128 plus 127. It will become 255. What you are saying is this is 250. This is for you 255, but for machine it's 255 with slash 17. Your router does not understand decimal, it understands binary. So it will do an AND operation and it will come to know, okay, the network address for this broadcast address is actually of this particular network address, not of this network. Got the point, guys?
Yes, sir.
Okay, I got that. But I have one question, please. I'm sorry. Huh?
Yeah.
Yes, I'm see that mean slash 16 is borrow 1 bit. If it borrow 2 bit, it's coming 18. It's true. That mean 128 plus 64.
Correct.
Is correct?
So until it's 24, it gonna be 255.
It's gonna be 192 actually. What we are doing at the moment, we are breaking it into 2. So we borrowed 1 bit. When we break it into 4, we will borrow 2 bits.
Yes. When you borrow 2 bit, that means it's coming 192. That means it's 18 slash 18.
Slash 18. Correct. But what is
128
happening
plus
at the
64.
moment? You understand what is happening at the moment when we borrow 2 bit, how much is we are consuming? 164 plus, sorry, 128
plus 64.
192.
192. Yes.
From
From
255 we go to
192.
192. What is the block size which remains? 3. And then what?
192 to 255.
Huh?
Sorry, come again.
What I'm saying is, if we borrow 2 bits,
okay,
then what would be the remaining number of host bits available?
From 256 minus 164.
No, don't use that 256 method. Don't use that method. Okay.
Okay, so it will be.
I mean, it's pretty straightforward, right? This is all 255. Correct? What we borrowed is 128 and 92. We are not going to make any changes here. Let me show you that example. So we are breaking it into 4 places. So I mean, first we did is into 2 pieces. Let's say the IP was 152.160. Let's say this is the network address. Okay.
Not there. I'm putting.
Guys, can you please stay on mute if you're not speaking? I mean, if you don't have anything to ask or answer, then please stay on mute. Yeah, so this is the subnet. When we are breaking it into 2, what we are doing is, see, we have 2 hosts octets, right? 6, 7, and let's say 8. So this is this one, okay? Because we are going to borrow from the third octet. We are going from left to right, correct? So we borrowed first to break it into 2, 0 and 1. If we want to break it into 4, we need to borrow 2 bits. So let's say we borrowed 2 bits, okay? Let's say we borrowed 2 bits. So what is the first address? So what would be the number of network bits then if we borrow 2? 16 plus 2, 18. Come on. So 152, 160, no changes here. Now the value assignment comes on these, when I say no change, I mean this is what we did for the third octet. but
Network not change. The network not change.
network no changes, correct? And this is host, and we borrowed 2 from here. But what are the possible combinations? What we can do is 0 0 0 1,
0 0.
yeah,
It
1
should
0 1 1. These are the 4
1
possible
1.
combinations, correct?
Yes, sir. Yes, sir.
So this would be first block,
Yes, sir.
this would be second block, this would be third block, and this would be fourth block. So what is gonna be the
Yes,
first
sir.
address? Again, because these are 0 0 and you know everything is 0 in the network address. So again /18.
Yes, sir.
Here what is gonna be? This is not, this would be the first one. And then once again, sorry, 0 1
So 0 0.
1 0 1 1, like this only, because we always come from this side. Yeah. So, and then what? 64.0/18.
Yes,
Then 128.
sir.
Correct? This is gonna be,
128.0.
and then 192.
18.
So you see what is the block size? If you see from this perspective, block size is 64. So
Yes, sir.
what you did is 64 into 4, 256. How many
Yes,
number
sir.
of bits we have? 2 to the power 8 is this 256. So that is the
Yes,
that is
sir.
how it is, correct? So when we are breaking into when we are breaking it into 4, then what would be the block size? 64, correct? Got the point? That magic number theory of block size, what I was telling you earlier. I mean, if you look, if you see into from a reverse perspective, that is how, you know, they, I mean, but then that is something you don't understand in that way. That is just like a kind of trick to calculate it. But I mean, you should know how it is actually happening. So the block size is 64. Now my one network is of 64 bits. I mean, yeah. Not the bits, because I mean, you guys don't even say that, not the bits, because the overall stuff is 32 bit. I mean, but yeah, the block size is 64, correct? So the first address of this this address block is gonna be 0.1, and the last address would be what? Come on. I'll remove this 128.64, basically 192 from 255. What is gonna be the address? Come on. Oh, it's that confusing, is it? So let's say, just to, how many it is, 6 7 8, okay, and then let's say the last octet. So this becomes 1. They all are 0. They all are 0. The first address is 152.160.0.1. What would be the last address? They are reserved. They are 0 0 at the moment. We are not doing anything. So these all are 1. These all are 1. These all are 1. They become 255. They also could have become 255 if these were the ones, but they are not. And what are these places? 128 and 64. So 128 plus 64 is what? 192. And the total is 255. Even if you don't talk about the total, let's 32 plus 16, 48, 50, correct? 48, yeah. 56. And then 7 is what? 63. Come on, man. 0 to 63. 152.160.0.0, 63.0. So 0 to 63 is what? 64. That is what we are saying again. 256 into 4 blocks would be 64, would be your block size. Correct? That is where the second octet, after this, the second address starts from 64.0. Correct? Then if I add another block size, then it starts from 128.0. Then again 192.8.0. Getting my point? Hello, guys, please.
Yes, yes, of course we get.
Yes, sir. Yes,
Of
sir.
course.
All right. So this is what I mean. This is what when you break it into 3, 2, 4, 6. I mean, this is what I mean. I mean, this is what we're talking at the moment is classful. So when you say classless or variable and subnet masks, at that point we don't talk like this, that 4 subnets or 5 subnets. No, what we talk is I need 64 hosts in this particular IP network. I mean, in this network address. What I'm gonna do? So what we do is I'll tell you that later. So that is how the real application part happens. This is you can say top to bottom approach. But when you understand this approach, you will understand sort of reverse engineering, because that is a reverse way of doing things. Okay, but because I mean this is the wastage of IP addressing in this in this manner. Because let's say if I need only 64 IPs, and if I have this address, how many addresses is gonna be wasted. Let's say I have this address and I say I need 64 IPs only. Then this way I can get 64, but then the remaining 3 blocks are unused. But if I didn't do the subnetting, what would have happened? It's like the bigger room, I have 64 chairs placed, and then the rest of place is unutilized. So why I mean why we do subnetting? It's not just that we are breaking it into rooms. There is another point. I mean, for you understand this example, for example, this is LAN. These are the switches, okay? And there are n number of machines which are connected to this device. These all are PCs. Let's say 20 machines are connected, okay? And you are saying, let's say this is a LAN, and here let's say this guy is Alok, okay, and let's say this is Vishnu, and Alok is broadcasting who is Vishnu. So this packet is getting everywhere. We talked about broadcast domain, correct? This is going everywhere, but then who is going to respond to it? Only Vishnu. And rest of the people, what they say, hey, who is this idiot shouting? Why are you shouting? People who are sleeping silently, you are disturbing them when you are broadcasting in such a bigger group, right? Though you will discard it, but some would be, what nonsense is this? Somebody say, hey idiot, stop it. So what we do, I mean, this is a generic example. But then if we have a bigger number of people in one single group, it's very hard to manage this stuff, to manage them. So why we do subnetting? Let's say these 4 people are in a different department. Let's say they are HR people, and let's say these are sales people. Still, Alok's message is getting to sales to HR, but he needed somebody from HR only. But sales is also getting it. Let's say IT is also getting it. Yeah. Then what is the point? So to limit your broadcast domain, we do subnetting. This is one of the, you can say another example. The management of the people or the IP addressing is easier management, because I mean, if this is the group where they need to communicate, I mean, if HR people need to communicate with HR, why should they communicate with others, right? And let's see, I mean, this is a very basic example. Let's say a lot of people, I mean, everybody is saying something. A CPU, there would be a lot of CPU utilization, correct? Let's say if everybody is shouting to everyone, asking for somebody, this guy is getting only 1 packet which is useful for him, but then the 19 packets are useless packet for him. But still he's using his brain to process that packet, those packets, correct? So that, I mean, these are ineffective ways of management basically. So why we do subnetting? These are, I mean, you will understand it better, but whatever we have learned until, so you can say these are the reasons that why we divide it. So I mean, in a simple language, it's better management basically. I mean, why you do different rooms or shelves in your room, so you can put your stuff in a systematic manner. You can manage, you can find it easily, correct? Otherwise, I mean, I mean, it's pretty straightforward, common sense, correct? So that is that. But in technical terms, this is what these are the reasons why we do subnetting, and that to stop and to avoid the wastage. Because I mean, if this is the house, and if I make it like this only, everybody has their equal portions. or they might not be using equal portions. And let's say this guy is using this much of his space and this much is his wastage. So that is where we will talk about VLSM, variable length subnet mask. Okay, we'll talk about it, not today because it will be a complete answer for you. I mean, in the very first classful subnetting and all, you guys, I mean, it's natural. There is, you don't think that you are not getting it. If you're not getting it, it happens with everyone. I mean, when I learned subnetting, it took me a few classes and a few exercises to grasp it. Okay, so don't be like, okay, I'm not getting it. Okay, what is this rocket science? This is not rocket science. It's pretty straightforward. And similarly, I mean, because we're talking about classful, let's take an example of class C. So yeah, class C address range. I mean, if you don't remember, still you can answer because I told you the logic of those, bits reserved for each class. So if you don't remember the range, you can keep that in mind. Okay, what are the classes which are reserved for class C? Remove them, and then you calculate it, and then you tell me. Come on, guys. Come on. Bolo bhai.
So for the class C,
Yeah.
so 192.2223.
192.
2223.
I'm drawing the first one. Okay. Network. Host. What are the bits which are reserved?
110.
110. So how much is out?
So 223.
How it's 223.
Out, sir.
191.
191.
192. 192. How it's 191? 128 plus 64. So it starts from here.
192.0.0.0.
Correct? What is the last address?
223.
Huh?
223.
Remove this 32. Correct? This cannot be changed. This cannot be made 1. So you remove this 32. 120, 64, 192. I mean, or either 253 minus 32 because this can't be 1, right? These are reserved. There's nothing you can do here. They all become 1. Then what it will become in total 223. Correct? And then this again, they all are 1, 255, 255.0. So let's take an address of class C. Let's say 220.220.220.110. Okay. Now we need to break it into 2. Again, network. So we are not going to change anything on the network side. What we're going to do is we can only make a change on
Host
side. So let's borrow. Again, the possibility is 0 and 1. So this is my first block. What is going to be the address? Please go on mute.
225.
220.220.0/25. Correct?
Yes.
And then what would be the last address in this? 220.220.127.255. Correct?
Yes, sir.
And the second block, what is the network address for second block?
1.1. .1/25.
What 1? How can you say 1 here?
So 128/25.
This is the first address. Not first address. This is what? This is what? Come on, tell me this is what? First address, network address, what? Huh?
Network address.
Network address, correct. And the broadcast address is then 255, correct? So the first usable IP in this subnet? Come on.
.1.
What 129?
129.
We are talking about this one. When this become 1 and when this last become 1, 128 plus 1 become 129, correct? We're talking about last octet. 4, 5, 6, 7, 8. When this become 1, 128. When this become 1, 128 plus 1, 129. This is the first usable IP. Guys, I hope this is clear to you.
Yes, sir. Now clear.
It's clear.
This is how we do in Classful. I'm not going to teach you classless or CIDR or VLSM today because I can understand. Okay. Shall we talk about router switch or shall we continue in the next class? Okay, somebody.
Sir, you can give
okay,
us.
Mr. Pride, go ahead. You have a question?
So continue next.
So, Bride, you had your hand raised. So, you have any question? Some people are on totally silent mode. I don't know if you're getting. Oh, Sarah, you want to ask something? I don't know. Okay, no problem. So, what what do you want to continue today, or shall we continue in the next class, or what?
Sir, can you give us some more questions for
The next class.
subnetting?
Sorry, one by one, please raise your hand and then. Yeah, Ankit, go ahead.
Sir, I was asking you to give us some more questions on subnetting so that we can practice, and then for the further one we can continue in the next class.
Okay. Okay, so questions for you guys, huh? All right. Okay.
So we can practice it.
Correct. All right. I mean, do you want me to share some kind of document, or I can, write it straight for? I mean, okay. So come on. I mean, you don't need questions. What you need is this. Let's say 192.168.1.1. Okay. So what I'm gonna do is, about all the classes. Okay. A, B, C, D, E. Forget about D, E. We will talk about C, A, B, C. Their ranges, correct? Their range means the network IPs and the host I mean the network bits and host bits. So what you do, you take any IP, random IP, but again, I took one example where I said 270. So at least you should know that this is 255. It can never exceed 255. So I mean, though I'm gonna give you some examples, but still, I mean, you can take example yourselves. So what you do when you practice, actually, you write all the three classes, you write their ranges, okay, and then you take examples from any ranges, from any IP. For example, from class A, you can take any IP. For example, 54.54.11.11, for example. Then what you need to do? The question is pretty same. What is the network address for this IP? What is the broadcast address for this IP? What is the first usable IP? What is the last usable IP? Okay. And again, what you can do in this exercise, what you can add? Break it into 2 subnets. Break it into 4 subnets. Break it into 6 subnets. Okay. So 1, 2, 3, 4, 5, 6, 7. With one IP address of any range, you can do 7 exercises. Got the point? Okay, you make a note of it, and I'll give you a few examples, and then you can make a note of those, and then you can do as many as you want. based on what I just tell you. You know the ranges, you take the IPs, you take random IPs. Okay. Just don't exceed 255 in any octet, and you write whatever you want to write. So this would be better. I mean, this would be a better way. So you know, any octet can never exceed 255. So you write anything in any octet in all the 4 octets, but it should never exceed 255, and do it. Okay. So then when you write randomly, you will not think of this range. What you will do, then you will, after writing, you will think, okay, this is which class. Okay, this is actually this class. Then what I need to do next is these exercises. What the point? What I'm trying to say? So don't say that,
Yes,
okay, I
sir.
know the range and now I'm writing a IP from the class A. That way it would be a little obvious, but what you know is that it can never exceed 255. So let's write any random IP. Let's say 207, 201, 156, 184. Any random IP. Let's say 168.59.67.92. Any random IP. Any octet should never exceed 255. And if you want to practice until here, octet says, I mean class C, then your first octet should never exceed what? What? 128, 64, and come on. You guys are 32. Add this up. 192 plus 32. What it is? 234. How you will remember the range of class C? 3 bits are reserved. 1, 1, 0. So when this become 1, sorry, this doesn't become 1. I'm sorry. When this is 0, so 192 plus what? Or maybe 255 minus 32. What is 223? 223, correct? So I mean, if you don't want to practice beyond class C, so the first octet should never exceed 223. And then you do whatever you want to do in the remaining 3 octets. You're getting my point, what I'm trying to say?
Yes, sir.
Can you do exercise on this basis, what I just told you?
Yes, sir.
Yeah.
Yes.
So you do what you do I mean, you write random IPs, but first octet should never exceed 223, because we are not going beyond class C. Okay, and you make note of these points first. You make a note of these points. Then I mean, those who don't want to do a brainstorming, I'll give you some of the examples, some of the IPs. First you write that this is what you need to do, and then I'll give you some examples, and you do on those on the basis of those IPs. Once you're good with I mean, once you're done with those IPs, then you can take examples of other IPs yourself, and then you can do it further. So if you have made a note of it, maybe if you don't want to, I mean, I don't write very neat and clean. Otherwise, I mean, if you don't want to write, you can take a snapshot, save it, and I'll put some IPs. I mean, if you don't want to write, don't write, take a snapshot. Okay.
Yes.
All right, then I'm gonna remove it. I mean, I hope everybody has taken the snapshot. Okay. Nand Kishore. Okay, I'll talk to you. Okay, IPs. 11.23.57.64. 1, 2 is 23.64.92.91. 3, 37.37.64.72. 4, 39.82.61.79. Fifth one is 81.72.6.132. Next is 6.9.181.220. 16.19.128.149. 116.192.192. 248. 9th is 221.207.162.190, and 10th is what? 28. 127. Okay. 127. 140.64.32.168. 11th is 152.192.6.6. 12th is 169.154.11.13 is 7. Okay, 1 second. Let's make it 166. 7. 19.11.66. Okay, so these are the IPs. You can take a snapshot. You do the packet.
So what's the eighth one?
116, 192, 192, 258, 248. You can write anything.
248.
248. Yeah, it's 248.
The eighth one is not valid.
Why it's not valid?
Sir, it's
248.
It's 248, not 298. Okay.
248. Yes, sir.
Yeah. Okay. All right. Though I wanted to do a lab today, but I think next class it is, which is gonna be our lab
Maybe
class.
a simple lab with a router.
Today. What do
Maybe
you
a
want to
simple
see?
lab with router and 2 PCs.
I mean, what is the point if you don't know the commands? If I write something, if I execute the command, if I do some telnet ping, you won't understand what is the meaning of that command. I mean, it will feel good, but then it doesn't make any sense at this moment. So we'll do it in next class. Okay.
Sure, sir.
So I hope you have taken a snapshot or
Or
whatsoever.
else you can show us EVNG, a simple EVNG
How to? I mean, a lot of people have already left. I don't know if they have left intentionally or what. So I mean, I'll do that in a class where when everybody joins, so it would be from scratch. When everybody comes up with a fresh mind. So I mean, it will be again additional stuff for today if I show you EVNG. But I mean, again, keep that VMware ready, okay?
Okay.
Installed, and you can maybe, I mean, that, or you can go to evng.com. You can download that OBF from there. I mean, at least I can show you that.
Yeah.
But again, there are people who need to know that. Maybe we will repeat. Let me stop recording, or maybe let it be. EVENG. So you go to EVNG, okay, and then downloads. It's available here. This is a pro version. We don't need pro version. Okay, VMware Workstation is also here available, so you can download it from here. This is a pro version. This is again a pro version. Where is the free version? Community edition. Okay, here it is. Yeah. So you can download anything. You can download, don't download ISO, download a OBF file, either from Mega or from Google. Okay. So download it, because OBF we can directly export. Otherwise, for ISO, we have to do a proper installation, how we do for virtual files in VMware. So we don't need to do that. OBF can be imported directly. Okay. A lot of Excuse me. Well, these are today's comments or what? I'm sorry, I did not. So you can, you can go to this website and you can download it. Okay. And let me also address a few of the comments. People had some comments. Let me stop recording first. So when we do, you at least have these things ready. Okay.